Mean life. Now, mean life of any element, that is the summation of the lives of all nuclei divided by total number of nuclei. That is the mean or average life. Now, suppose here at time t equal to 0, number of nuclei, that is n0, and at time t equal to t, number of nuclei, that is n. Now, in time t plus dt, suppose dn number of nuclei disintegrates. In short, we can say in time dt, dn number of nuclei disintegrates. Then dn nuclei have the lifetime t, that is total life of dn nuclei. So that is t into dn. Okay. Now, total life of n0 nuclei. So integrate this equation, 0 to n0 tdn. And now mean life, that is represented as tau, that is equal to, now see here in definition, the sum of the lives of all nuclei. So that is integration 0 to n0 tdn upon total number of nuclei n0. But now we have equation n equal to n0 e raised to minus lambda t. So if we differentiate this one, dn by dt, that is minus lambda n0 e raised to minus lambda t. So minus dn by dt, that is lambda n0 e raised to minus lambda t. Okay. Now here we have the equation tau, that is equal to integration 0 to n0 t into dn. But now from this particular equation, we can write dn, that is equal to minus lambda n0 e raised to minus lambda t, and take this dt on right hand side. So t into minus lambda n0 e raised to minus lambda t dt upon n0 as it is. Now, in integration, you do this thing when you change the limit, then sign will be changed. So now 0 to n0, that limit is changed from n0 to 0, lambda t n0 e raised to minus lambda t dt. But now we have to change this particular limit in terms of time. So n0, that is the number of nuclei at time t equal to 0. So now see in this integration, here the lower limit is taken as 0. And the number of undecayed nuclei will be 0 after how much time? We don't know. After infinite time. So upper limit is infinite. So here when the integration, that is of t with respect to dt, so limits are also changed for time t. Now n0 cancelled. So tau, that is lambda integration 0 to infinite t e raised to minus lambda t dt. Now, no need to solve this one. Answer of this one, that is 1 upon lambda. So tau, that is equal to 1 upon lambda. Clear to all of you? Again, mean life. The time interval in which the number of undecayed nuclei becomes 1 upon e times the initial number of nuclei. That time interval is called mean lifetime. Now see, here we can write at time t equal to tau. That is the mean lifetime. The number of undecayed nuclei, and that becomes 1 upon e times the initial number of nuclei, means n equal to n0 by e. Now we have equation n equal to n0 e raised to minus lambda t. In this one, substitute t equal to tau. And at that time, your n, that is n0 by e, n0 cancelled. So we can write here on left hand side 1 upon e, that is e raised to minus 1, that is e raised to minus lambda tau. So lambda tau, that is equal to 1. Here compare the power on both the side. So tau, that is 1 upon lambda. Very simple equation. Now when tau, that is 1 upon lambda, and half-life t1 by 2, that is 0.693 upon lambda. So here we can write lambda, that is 0.693 upon t1 by 2. Substitute this particular value of lambda here. So we can write tau, that is equal to t1 by 2 upon 0.693. 1 upon 0.693, that will be 1.44. So we can write a tau, that is equal to 1.44 t1 by 2. Or we can write t1 by 2, that is equal to 0.693 into tau. So the relationship between mean life and half lifetime, that is this one. Clear to all of you?